everybody. Thanks for joining me today. Today's topic is failing gracefully, exception handling in Deluge. A little bit about me first. I've been a Zoho partner for the last 3-ish years, since March 2020. Before that, I was in the Salesforce ecosystem, so lots of CRM experience on multiple platforms. I'm a Care Growth Strategies is a one-man band, so to speak. I'm the developer, consultant, all in one. Just really passionate about learning new technologies and figuring out great new ways to do things. Really and passionate about process improvement, especially. So it's a little bit about me. Today, I really hope that you walk away with a little bit more knowledge about exception handling and preventing failures in your code. We'll go over a little bit advanced usage. It's certainly not going to be a 100% complete coverage of everything that you could do, but hopefully we're going to get through the basics and in the next level of usage of try catch and exception handling. And then we'll talk about how to track multiple exceptions with an example, and then a little bit on how to make them actionable. So I have, in a previous life before I started consulting, I ran some application support teams, and so we had to get really good at troubleshooting. And so a lot of this is a passion project for me, both from a developer standpoint and as somebody who might have to support your code someday. So hopefully we all get a little better after this. So quick exception handling intro. So the difference, you'll hear today me talk about exceptions and errors, and I'll probably use them interchangeably. But realistically, if you look at like other languages, there seems to be a fairly a discernment between an exception is kind of like a little speed bump or a little hiccup in your script or program that can be dealt with and reacted to, where an error is typically like a catastrophic failure. In Deluge, they're really one and the same, right? If there is an issue with your script in Deluge, like it will fail. So, but if you get into the theory of it all, the exception is technically what it's called. But you'll hear me go in and out because they are fairly similar. When I say gracefully, what I mean is that you not only are you failing when you expect to, like if something doesn't happen, but also that you're able to handle any unforeseen situation and be able to actually take action on it. Like, so it's not just like, oh, it failed and it's a surprise. It's I knew it was gonna, or I didn't know it was gonna fail, but now that it has, like I know that I'm aware of it. I know that it happened and I can do something about it. Which brings me up to the expected versus the unexpected, right? I think a lot of us code for all the expected issues, but we don't think about necessarily what is unexpected. And sometimes the unexpected can really outnumber the expected number of scenarios. So we'll talk about some techniques to help with that as well. So next slide. So here's your basic try-catch statement, right? And I'm assuming that most of you are familiar with it. If you're not, we'll just do a quick run through here. So basically what happens is it'll execute the code in the try part of the statement. And if there is a functional error, it will automatically move to the catch the catch part of the statement, and it will execute whatever code is in that section. So in this case, we're going and we're fetching the website zoho.nope, which obviously doesn't exist, and then trying to get the length of the web page that we have. That's going to fail every time because there's nothing called zoho.nope. So what will happen though, and the really important part of all this is, if you run it with a try catch, you're going to get something like off to the right. Zoho is going to assume it executed successfully, right? It is, even though an error happened, right? What the try catch does is it's saying, I'm taking control of the error, right? I'm not just saying like, Zoho, something bad happened. I'm saying, yeah, I know something bad happened, but I'm going to do something about it. I got it, right? And so from Zoho's perspective, it executed successfully, even though obviously our log there says error line 5. This is successful. If you compare that to just running that same code without the try catch statement around it, that is where Zoho goes, oops, something bad happened. I don't know what to do. I'm stopping right now. And so that's the difference there. And that's a really important distinction to understand. So you're probably saying, hey, should I always catch exceptions? And in general, yeah, like you really should. You should be knowing when you're failing and doing something about it. But there are exceptions. Like for example, in Zoho Flow, it kind of has it built into the platform where if there is an issue with a function that you do, if there is an error, then you can do other actions. So it's basically extended the try catch to outside of the function. But it does basically the same thing. Either way would work, but like in this case, it's kind of already handled for you. You're probably thinking like, can I just use if statements to do my checks? And the answer is yes. Like you probably should as well, right? Do check for the stuff that you know. But what happens if something you don't know happens, right? Like say an API you're calling changes the spec on you and you're getting a different result, or it doesn't return the same structure or whatever, right? Like stranger things have happened. What happens if you just make a coding error that you don't think of, right? Like these are the unexpected errors where doing exception handling with a try catch really comes in handy and can save you a lot of headaches. The most important thing, though, is when you're adding these, don't just add them willy-nilly. Don't just like wrap everything in a try-catch just for catching's sake, right? You really need to focus on what is the resulting action of that error, right? And so if you're just saying like, no matter what happens, if I don't get a certain result, or if there is any error that happens during this particular function, then I want to catch it, then fine, right? Then wrap it in try-catch. But as I'll show you in a minute, there is a smarter way to do that. But when you're deciding whether you should, think about like what would I do if there is an error, and if there is a difference between two sections of your code, you should wrap them in two different try catches. So now we're getting into the advanced part. So kind of advanced. Like I mentioned, wrap each block of code in its own statement relative to what you want the outcome or the action to be, right? And so that's really important. Of course, you can go overboard. You could wrap every single line of code in a try-catch statement, but that not only would that make it hard to read, but also wouldn't necessarily be productive. But there is a happy medium between wrapping a chunk of code and doing something after or if there is an unexpected error or an expected error. But really, you want to focus on isolating the actions, right? And so things you can do is you could, try again, right? Like sometimes APIs are unreliable and you're just like, well, if it didn't do it one time, I'm going to try one more time before I give up, kind of thing. Okay, fine. You can use a backup data source, right? If you've got replicated servers that you're hitting, maybe you hit one replicant and then you hit the other one if it's not, if it doesn't have automatic failover, that kind of stuff. You can create a log entry anytime an error happens, right? Like so, the log can be either within your system or external, or you just want to notify somebody, hey, there was an error. It happened in this context. Now I want to alert them and let them know so they can do something about it. Something else you can do, you can also embed try catches in each other, right? So like I mentioned on that retry action, say you're going after an API and it fails. In the catch statement, you can actually put another try catch that does it again, just to make sure that it's failing safely and gracefully, as I like to put it. One of the other advantages is if you do this, like so, say you have multiple try catch statements in your code, you can actually start to approach like a stack trace type of tracking where every time there is an error, you're adding to a list of errors so that at the end, you know exactly what happened and where issues happen. And again, we'll cover this in an example, but that's one of the big use cases. And then on top of that, you've got that list of errors now from catching it going down the line. Now you can actually return that along with the result of the function, and then you can kind of like really stack them up, and you can collate them based on all of the different functions and all of the different calls that you make from there. All right, so now to the fun part. So I put together a very simple, over-engineered example of a creator app. It's basically going to track the city temperatures or the temperatures for the current temperatures for certain cities. Something that you could run on like a cron job or like a scheduled job, or in this case, we're just going to push a button and update it. One quick thing to note. The API that I did use is not to be used for commercial purposes, so I am sharing this code, but please do not use that API in your applications. There are other ones out there that you can use, but since this is educational, I think we're safe. So here we have a very simple thing. So here are 3 cities that we want to track: Airville, New York, and Durham, North Carolina, where I'm at. We put in an address. We're going to track the temperature in Fahrenheit, because we're in the US, and when it was last updated, and any errors that have occurred during the processing. So we'll show why that is useful in a bit. So here we go. So I'll just do a quick example of how it works, right? You refresh the temps, it runs through the job. Clearly something happened over here that we'll show, but these two seem to have updated perfectly fine. So without further ado, we'll hop into the code. The main function that's going to be doing all the work is this current temp, and so I wrote it in 3 different ways: one that has error checking, one that doesn't have any error checking, one that has some exception handling, and then probably a better, more over-engineered one. So let's start with the base logic. So here we have it's really just doing the baseline logic. So it's going to take the lat and longitude from the address that comes directly from Zoho scrubbing. It goes and fetches the weather. The weather response, the example is down here, so you can see like kind of what it would look like when it's successful. It's going to fetch it out of the item, out of the payload, and then convert it to Fahrenheit, and then return it as a number. So if we comment out our test data and we run it, everything looks good. It gets the 53.78. Full payload, everything looks good. That looks great. What happens if we're missing a number? Oh no. So again, Zoho doesn't know what to do. It's failed. You can see here, this is the payload from the API, basically saying the longitude is missing, and so that's why it's failing. So let me comment this out. So again, this is your base version of how you're doing it if you don't want any exception handling at all. A better way to do that, the improved version, is we're wrapping it in a try-catch, right? So we're just basically saying, if I don't get a successful temperature in Fahrenheit, then I'm going to catch that, and I'm just going to return a default value of -999. The reason why you would do that is because theoretically -999 is not a possible number of a current temperature anywhere, and any function that's calling this function can use that and assume that, hey, like, if I see a really low number, if I see this specifically low number, then I know something went wrong and I should discard it, ignore it, take a different action, so to speak. So in this case, I'm going to do the same thing. Just going to run it again, but missing longitude. So this one is going to fail. Notice how it resulted. It was successful, but it returned the bad number. So again, Zoho, from its perspective, thinks that like, hey, everything went great, no problems, no issues. But in reality, we had a problem and we gracefully handled it, right? Like, so now whatever's calling this, if it sees a negative 999, it can take action and go, hey, this is a problem. Maybe I should tell somebody about it. If we go in and we do same thing, so if we do the same thing and it's successful, we'll get an actual real number there. Oh, the other point I wanted to make. So you'll notice that we have a couple of info statements here, temp in Celsius, temp in Fahrenheit, right? Well, they're not here, and why? And that's because as soon as you hit an error in the try catch statement, an exception, right, it stops processing the code, right? So it goes immediately down to the catch and runs everything there. So we can tell, because these info statements didn't execute, that line 8 is most likely the line that it failed on, right? It failed when it tried to get the temperature from the payload where it didn't exist. So this is better, right? So at least in this case, we are getting a better way to handle the error, but there is probably a even better way to do it. So let me go back and we will go to logging. So this is the official one that the example uses. And what we're doing, the big things to notice, we're no longer returning a float, we're returning a map. So instead of just a single value, we're actually going to be returning a more complex response with context, and it'll even tell us whether, so it's going to explicitly tell the returning function how things went, right? So in this case, we can tell it was successful or it was an error. And then if it's successful, we're going to return a temperature. If it's an error, we're going to return the errors, right? And so the cool part about that is when you're returning the errors to the parent, the function that called it, you can then aggregate those up with any errors that happened in other parts of the function or in other functions it called, right? And so you can, again, create that stack trace of all of the errors that occurred in the run without just being able to get more context into everything that happens with your code. First thing here, so we're defining a list of errors, right? And so this is going to be our list where we are going to keep track of each error that happened in the list or in the function. We're also defining our default response and assuming that it's successful. You could also do a check at the end to make sure that there's a temperature in it and return successful there. Again, trying to keep things simple, but the important part is that we're going to be tracking all of the errors in a list. Another important thing is we've split the logic into two different try-catch statements. So the first try-catch statement is getting the data from the API, right? And so all it's doing is making that call and then fetching the temperature out of it in there. Now, one of the key things here is I could go ahead and check to see if current weather exists, and then I could also check to see if temperature exists. But in this case, if it's blank and it doesn't return it, it's gonna fail, right? So it's really up to you on whether you want to do that extra stuff or not. This is a lot easier to read, so depending on the type of code you want to build, that you really don't care why you don't get a temperature Celsius. You care that it happens, or that you just care if it happens at all. The other thing is, so when this fails, right? So say if we have a failure thing and it doesn't work, this is really powerful. So here's where I was talking about in this catch, instead of just logging the error, we could also go use another weather service, and we could go fetch an API. We could go fetch a different API, do something similar, and take another stab at it. You could also hit the same API again and see if that works, right? There's a lot of more flexibility in here where you can build, better, more resilient code as well. In this case, we took the easy way out and we're just logging the error. but it's really important to note that like this is one of the really cool parts about try catch. Another thing I'll call out is we can just log and add the error to the particular to the list, but in this case, I chose to give it a prefix, and you'll see why in a minute. This is just going to help and make it really a lot more easier to read and deal with overall. Then it moves on, and then we wrap the whole conversion part in a try catch, and then it's going to add that response, the temperature to the response. If there is an issue with the conversion, it's going to skip this line, right? It's not going to add it if it has any issue with the conversion. Again, very simple examples, but like hopefully you can see like how this can be extended to more complex logic. And then here, if there's an error, we're prefixing it with calc so that we know that something went wrong with the calc, the calculation part of the script instead of the API. Then down here, if there are errors, then we're going to say, well, it didn't. If there are any errors, then we're going to say it didn't happen successfully, and then we're going to return the list of errors to the parent function. And so this is going to give you a better return with more context around the status and the execution of the particular function. And as you'll see in a minute, it'll give you a lot cleaner way to deal with it as well. All right. So next, last part of the example is this is the function that the button calls. So the button that we went over in the front. It's doing the same thing. It's defining a list of errors that it's going to keep track of. It's going to wrap its code in a try catch. So not only can we report on and deal with any errors that come out in the in any of the child functions that get called, but we can also track errors and combine them with the errors that happen in this parent function as well. And so again, stack trace. So really simple code. So it's just going through each of the city records. It's getting the latitude and longitude from each of the records, and then it's calling the current temp function that we just went over, right? And so now we have a very explicit way to tell, hey, was this successful? If it was, I'm going to update the row, or update the record, clear out the errors, and set the last update timestamp. If it was not, then I'm going to log the errors against the record that was problematic, and then clear out the temperature. And I'm even going to do something else. I'm going to add the errors to the full list. I wrapped this in a try catch because in case there's any issues with the child function, where in the way that it's returning errors, if there's any issues, then we can really call out a very specific error because we know that it's only this line that can be problematic. So we can give it a very specific error message. Obviously, you don't want to do this for every line of your code, but hopefully you can see the value of being able to use try catches, multiple try catches, and handle the errors effectively. This is the catch for our overall function. So again, if there's an issue, we're gonna add it. And then at the end, this is the really important part. So if there are any errors, this is where you would want to take action. You don't want to send an alert every time an individual record fails, right? Like think if you have a lot of different records, say I had 20 cities in there and 10 of them fail. Do you really want to get 10 different emails on the for that when really you know that there was just one problem with this update job, right? And so this is going to simplify that. So again, it's just some random examples. You could take this and log it to an external logging service, right? Like Datadog or Loggly or anything else, right? Even Catalyst. You could send an email notification, make sure somebody knows about it, and then can take action. Or my personal favorite is create a click channel specifically designed for errors and notifications and send it there, right? And then if I see something go into that click channel, I know there's a problem, and I make sure that alerts are always on for every message, and so that I can take action. And I know that that channel should always be empty. And if it's got an unread, then I've got a problem, and I need to deal with it. But you could do anything, right? This is where the magic happens, so to speak. Last line is just we're refreshing the page so I don't have to do that myself. So that's pretty much it. So we'll go back here, and again, we run the refresh temps. What's happening is these two are successful. This one is having an issue, right? And so you can see here are our error messages, right? And like I said, the prefixes on here really come in handy, especially if you had a lot of them, right? You can see API error line 31, calc error line 45, right? So I can tell you that this is because it didn't return the values, but at least it gives you the reason why I say that this makes it more supportable is that when you read this, like this is very clear where you need to start, which is half of the battle anytime you're troubleshooting something with code, right? It's just getting to that starting point, like where's the error happening? That's half the battle. So this is extremely helpful. It helps you get there, right? And then so this is the important part. One of the another thing that I love, especially as the consultant side of me, is the concept of exception reports, right? So it's great that you get a notification that says, hey, something went wrong and here's a bunch of errors. But it's even better to know, well, okay, great. So I know that, but what are the things that I need to clean up? Where are all of my examples of things that are wrong? So what I like to do is set up exception reports that either send links to reports that give me a list of everything that failed, or send the whole list itself and just like literally give me the list so that I have it there. But I definitely recommend, one of the advantages of building in this error logging against a record is now you can create filters and easily generate your own exception report, right? And so now I can easily see, like, this is the one that's problematic. Yeah, I made it red coded as well, which also helps. But if this was a really long list of data, like really long, then being able to filter on specifically the ones that you need to fix can be super helpful. So and so as I'm going through, I'm going, oh shoot, you know what happened? I didn't give this a state. That's probably why Zoho isn't assigning it a lat longitude, and that's why the thing is failing. Now, obviously, Errorville doesn't really exist. However, if we refresh the temps after I fix it, now it's good, and my exception report is clean. So that's really powerful way to not only take those errors, but then make them practical and actionable, especially if you need to involve business users that may not have the same technical and developer skills that you have as well. So that's one cool example. Let me go back to my sharing screen, share files. And we'll skip ahead to some other tips and wrapping up. So a lot of times in other languages, there are ways where you can actually throw your own exceptions, right? You can literally write a statement that says, if something happens, throw an error, right? Zoho Deluge doesn't work like that, but we can approximate it and test our try catches by basically causing a failure. Now, the hard part is Zoho tries to help you, right? It tries to, it doesn't let you save like overtly bad code, like if you have a bad connection name or something like that. But there are several scenarios where you can force an error while still saving the record. And so this is the shortest and simplest one that I found to do. You basically just take a letter and try and convert it into a decimal, and it doesn't like that, but it will let you save. Super important. You need to be very aware of when you use these, and don't deploy to production with this in your code, because it will always fail. The better way to do your testing, or more robust testing, is to actually give bad inputs and then make sure that those inputs are failing. But but this is a way for you to do that if you're in a pinch. Last but not least, yep.
Oh, sorry. I just want to say that I believe there actually is a throws option in Deluge, that you can write the word throws, and then you're allowed a string to throw one of those custom exceptions. Or at least I know it works in like the CRM Deluge. Maybe it's different in Creator, but I know that you can write the word throws and then a string for like a custom exception as well.
That's a great tip. So ignore what I say. So if that's true, which it probably is, like, use throw instead. Don't do that. So that's great. I did not see that documented. I've never actually tried, but that's a great tip.
Oh, it's not documented, but it's when I found it when one of those times where you get that big block of red text saying, "Hey, I expected either a Zoho or an info or something," and I saw one of the words was, "Could at least send me like a throws or something." And I was like, "Throws?" I didn't know that was a thing, so I just wrote it on there, and turns out that's what.
I'll tell you what. When we finish, we'll go test it, because now I'm curious. But that it's funny, because that changes things. Because what I assumed, if you can't do that, right? You can't. There's a lot more options there when you can throw your own exceptions, right? Like, you can actually structure it to fail on business conditions, and then you can treat exception handling not only like actual like technical errors, but also business errors as well. So that's a really interesting tip. So thank you for sharing. Okay, so now I'm super curious. So we'll wrap this up, and then we'll go try that. So one of the important things, so as you're doing all of this, like, you're doing all that hard work to capture these exceptions and group them together, you want to make sure that you're organizing them, right? So you can, like we did, log the exceptions against a record. You can create a separate log module, log them there, whether in CRM or Creator or whatever. Or, like I mentioned, you can use an external logging tool to be to put them off to the side and track them that way. But then the most important part is that you're taking action, right? So something even as simple as an email alert to a group, or, as I mentioned, like click channels dedicated to error notifications. I will say, for your sake, it does help to isolate the most important groups or channels, so that you can, again, I can't tell you how important it is to be able to see a channel and know that it's something you need to jump on right away versus something you can look into eventually. And so making sure that you segment them by urgency, or make it so that that level of urgency can be customized depending on the alert, right? Like, I think it's easier to know that if I get an email alert to critical actions at carrotgrowth.com, right? Then I can set Gmail filters that make sure that they pop up, or I can, do something else, send it to my click channel, and really get my attention, right? Because we all get inundated with so many messages, emails, like everything every day. When you're running support and you're trying to keep an application or system afloat, being able to segment those is like the most important thing. So definitely think about that as you're designing your exception alerts. And then I will also add, one of the really cool parts about Click is that you can build actionable messages, right? And so here I have an example of something you can build with the message builder. And so it gives you a lot of context, a lot of information about what happened. But the most important part there is down at the bottom. You can put buttons that help you get to the information that you need, or even something as simple as rerun the job, right? Like, oh, it failed. Oh, yeah, it always fails if it runs at this time. I need to just run it again, and it should be good. But again, that can be anything, right? And so that's super powerful when you're talking about making urgent, actionable alerts that your team can dive into. So that is all I had. Are there any other questions that we have? Otherwise, I want to go test that throw.
Oh, there are a lot of questions in the chat. Yes, please go ahead.
Oh, I was going to say, one thing that I really like doing with because I've started doing the kind of that error list, Mike, that you showed, you know, at the end of your code. I like to take it one step further and adding like a map to that error list, where like I'll have like the error and then the error message, and then also adding in, like, because if you can kind of think of any try catch as like a mini function, right? So like there's some kind of input arguments that you could say are happening, like what's the stuff that's going into the try, and so if you include those along with the error message, you might be able to figure out faster what exactly went wrong, right? Because it's never the error message is almost never exactly what went wrong. What really went wrong was something 3 steps before.
Absolutely correct. Absolutely correct. No, that's great. Yeah, and I think I've even done that before. I was trying to keep the example as simple as possible. That's a great tip and call out.
If you build your error message as like a map, then similar like what you have, where all the going into a text box at the end, then you can just copy and paste that into a nice little pretty JSON viewer, and reading those kind of error messages can be a little bit easier because you'll have something that can format that really.
Awesome. Well, yes, it has been confirmed. The keyword is throws. So, wow. All right. I'll update. I'll give me a few minutes. I'll update my code and update the repo with the changes. But yeah, just the code is in a link on the last slide of the presentation for this whole app, and you can just import it into Creator if you want to take a look and try this yourself. But I'll fix this and update it with this example. But this is that's great. It was a great tip. That's so much better.
The one thing that I wish throws also did was, now you can only put in a predefined string in throws. Like you couldn't include a variable in the throws string.
Yeah, I hear what you're saying. Yeah. So you which I guess kind of makes sense, but yeah, you have to be very explicit with your thing. That's still good. I mean, it's still better, right? Because then you can actually say, yeah, like, if a does not equal 0, then you can actually throw an error and then do something down here, rather than just like, oh, if some exception happens. So that's great. Good. I'm glad I got to learn something too. That's awesome. Appreciate the input.
Yeah, it's especially useful for like if you have like a for each loop and you got a big try catch inside of your for each loop, and you're like, well, I know that if I run into something up here, that there's no point in doing the rest, even trying to do the rest of the loop, because it's going to hit an error, or I'm at least not going to get anything good, and then you can just kind of hop on it.
Get yourself a code share of the week. Awesome. Well, unless anyone has anything else, that's all I got. I appreciate everyone's time, and again, you can reach out to me on the in the Click channel. Happy to help and interact with all of you, and let me know, or you can reach out to me on my website.